So if you didn't get it, the answer is B for 53. Which of the two musical notes displayed one at a time on the horizontal screen below have the higher pitch? Well, the higher pitch is a higher frequency, A. And so the one with the shortest wavelength will have the highest frequency, A. So this wavelength is from here to here, while this wavelength is from here to here. There. So this one would have the higher pitch. And for 54, the answer that you need to record is D, again, as in dog. 55. In the oscilloscope screen shown in the preceding question, which one displays the louder sound, assuming detection by equivalent microphones? And for that one, it's the amplitude, which would be from the baseline, so it would be from here to here versus here to here or here to here. Therefore, this is the correct one, and the answer to 55 is E. Which is a more objective measure of sound intensity, measurement, sound intensity or loudness? Loudness is subjective. That's through your mind. Objective is something you can actually measure, so it's sound intensity. And for 57, the answer is H. For hell? No. 58. One person has a threshold of hearing of 5 decibels, and the other one has a one of 10 decibels. Which person has the most acute hearing? Acute means can hear the softest sound. The softer sound would be 5 decibels, so it'd be the person with 5 decibel hearing. And that would be, answer is F, as in Frank. The frequency range of a telephone is between 500 and 3,000 hertz. Why doesn't a telephone do a very good job of transmitting music? Music covers our whole range of hearing, something like 20 to 20,000 hertz. This is only a very small subset of it, so that it doesn't, we lose all the higher frequency notes and a lot of the lower frequency notes. So it's not a very pleasing music transmission. Also on a phone, this is why the letter S and the letter F sounds exactly the same, because the difference between S and F lies in frequencies outside this range. And the answer to this one is J or J. 64. The note middle C on a piano has a fundamental frequency of about 262 hertz. What's the frequency of the second harmonic? The second harmonic is twice the fundamental or the first harmonic, so 2 times 262 is 524. And the answer to this one is K, A, as in no, or knowledge. If the fundamental frequency of a guitar string is 220 hertz, what's the frequency of the second harmonic? Twice that, or 440? And the third harmonic would be 3 times, or 660. And the answer here is M, as in master. If the fundamental frequency of a guitar string is 440 hertz, what's the frequency of the second harmonic? Twice that, 880. And the third would be 1320, or 3 times 440. And the answer to this is O, as in onion. How many nodes, not including the endpoints, are there in a standing wave that is 3 wavelengths long? How many nodes are there in a standing wave that is 4? So 3 would be that would be, not including the endpoints, 1, 2, 3, 4. 5. And for 4, 1, 2, 3. That's 1, 2, 3, 4. And so it would be 2 more, or so there would be 5 here and 7 here. Just as an earlier question in the other chapter. Oh, and the answer to 67 is going to be N, as in nodes. 68, an outdoor concert. The pitch of musical notes are not affected on a windy day. Why? Because the wind will affect the speed of the wave, but not the frequency. So the wind does not affect the frequency, so the pitch will not be affected. And the answer here is T, as in tone. 69, the human ear is sometimes called a Fourier analyzer. What does this mean, and why is it appropriate? Because when multiple sounds are reaching us at the same time, our ear only responds to the summation of them. Yet we can break out different sounds, as in a guitar sound versus a piano sound versus someone singing, or different friends talking simultaneously. And that's why it's appropriate. And the answer here is U, as in umbrella. 70. The width of a laser beam was and is significant in reading CDs and DVDs. The thinner the beam, the closer the series of pits could be. Why will blue laser light allow closer pits than red laser? The width of the laser beam deals with the wavelength of it. And the wavelength of blue is smaller than red, so the pits can be closer together. And the answer here is B, as in beam. How can you tone the note A on a piano to a proper frequency of 220 hertz with the aid of a tuning fork, whose frequency is 440? Well, when the piano string is sounded, it won't vibrate just at its fundamental, which is 220. It'll vibrate as second, third, and fourth harmonics. And we only care about the second harmonic. So let's say that it was actually set at 221. That means that its second harmonic will be vibrating at 442. So that we would hear a beat of 2, beat frequency of 2 between the two. So we can adjust it until there is no beat frequency, and then we know we have it correct. The answer is O for object. And 76, a trumpet has keys and valves that permit the trumpeter to change the length of the vibrating columns and the position of notes. A bugle has no such keys or valves, yet can sound different of various notes. How does this happen? Basically, the bugle has only one fundamental frequency, but it also has all of its harmonics. The second harmonic, third, fourth, and fifth, and they can all have different amplitudes. So by the way he holds his mouth and how he blows into it, he can emphasize one harmonic over another, and effectively changing the pitch of it. And that's how he makes different notes. And the answer here is S for simple. All right, now go to the quiz and put in your answers. Thank you.